So first, let me introduce you to the Z parameters, or also called as the open circuit impedance parameters. Okay, see, so before going to first, I will tell you how to remember the equation, then I will write the equation. Okay, we all know what is the meaning of Z. We have seen this letter many times in the subject. So Z parameter means impedance. So what is the meaning of impedance? Impedance means more like a resistance, right? We can think of impedance like resistance. So we all know the equation for resistance, right? That is, we all know Ohm's law, that is V is equal to IR, or if it is an impedance, we say V is equal to IZ, right? This is how we express. That is, this V actually stands for voltage, and this IZ actually stands for voltage potential, right? Potential voltage or potential difference. So therefore, this is how. So basically, Z parameters means nothing. So immediately when you see Z parameters, you should understand that Z parameters is nothing but your normal voltage equations. That's what. That is, you are going to express the voltages. So how many voltages are there? There are two voltages, V1 and V2. So what you're going to do is that you are going to express V1 in terms of I1 and I2, and you're going to express V2 in terms of I1 and I2. That is called as Z parameters. That's all. It's just like your Ohm's law equation or your mesh analysis equation. Okay, that is, this is how we write. That is, the equation for Z parameters is V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. This is how we express the equations. This is how we express the equations. Okay, so here, as you can see over here, these are the different parameters. These are the different ways of parameters. As here, if you can see, you are expressing V1 in terms of I1 and I2. We are expressing V2 in terms of I1 and I2. And here you can see, look at this equation and look at the numbers over here. Z11 I1. So you basically, from here you can understand that this one represents this one, and this one represents this one, and also Z12 I2. So this one represents this one, and this 2 represents this 2. Like over here also, V2 is equal to Z21 I1. So this 2 represents this 2, and this 1 represents this 1. And over here also, Z22 I2. See, so remembering this equation is very easy. Okay, and also not only remembering the equation, but once if you remember the equation, then you know how to find the values. Then you will be able to find the values of each of these parameters. Okay, so Z parameters means Z11, Z12, Z21, Z22. These are the 4 parameters for Z parameters. So this is what you need to find. You need to find the value of Z11, you need to find this value of Z12, you need to find the value of Z21, and you need to find the value of Z22. This is what the question will be asked. You need to find each of these parameters. Now, how to find the values of each of these parameters is very simple. For that also, all you need is simply look at the equation itself. For example, okay, you are trying to find the value of Z11. Okay, so what is the equation of Z11? Simply look at the equation. Simply look at the equation. You will be able to write the value of Z11. So what is Z11 is, if you ask me, by looking at this equation, I can say that Z11 is equal to V1 by I1. Okay, Z11 is equal to V1 by I1 only if this term is 0, only if this parameter is 0. So Z11 is equal to V1 by I1 if there is no second term. You see, there is no second term, then Z11 is equal to V1 by I1. So how will I remove the second term? By putting the value of I2 is equal to 0. See, so that is how it will become so easy to remember. So therefore, what is Z1 is, if you ask me, Z11 is the ratio of V1 by I1 when I2 is equal to 0. That's it. This is how you remember each of these parameters. You can find the values of each of these parameters, and for any other network parameter, not only for Z parameters, for all other parameters also, you can express them in terms of individually by simply looking at the equation. by simply observing the equation. Okay, so here I can write, now I can find the value of z11. So now what will be the value of z12, or what is the, how to find the value of z12? Z12 is nothing but v1 by I2. Okay, z12 is v1 by I2 if this first term is 0. And how to make the first term 0? If I make I1 equal to 0. So therefore z12 is v1 by I2, is the ratio of v1 by I2 when I1 is equal to 0. In the same way, what is the definition of z21? Now you can tell me, right? Now you can say it by yourself. What is the equation for z21? Z21 is, if you look at the equation, z21 is v2 by I1 when I2 is equal to 0. And what is the equation for z22? Z22 is equal to v2 by I2 if this term is 0, or if I1 is equal to 0. See, so this is how we find the value of each of these network parameters. Okay, so in the exam what they do is they'll give you a network and then they'll ask you to find the Z parameters, and finding the Z parameters is very easy. You can, one way of finding the Z parameters is you can find the ratio of these two, of any one of those parameters, keeping the other necessary current to be 0. You make the current, the corresponding current is 0, and you can find the network, you can find the Z parameters. Or what you can do is you will try to express your equations in terms of V1, I1 and I2 and V2, I1, I2. If you are able to express your network equations in terms of these equations, then by comparing the equations you can find the value of Z11, Z12, Z21 and Z22. That is also another way of finding. So whichever, there are a lot of ways of finding the value of Z parameters. Okay, there are so many ways of finding these parameters, but which method is good for which problem, that depends on how much you practiced. Okay, so this is how we call as the Z parameters. Now what I'm going to do is, this is what you call as the Z parameters. So now what I'm going to do is I'm going to find the conditions of reciprocity and symmetry for Z parameters. That is, by looking at the Z parameters, how can I say if the network is reciprocal or not? So to do that, what I'm going to do is I'm going to apply my conditions of reciprocity to my Z parameter equation. So conditions for reciprocity. Okay, so what is the meaning of reciprocal? We have discussed that in the previous video. It means that if I take a two-port network, okay, I will take a two-port network, and then what I'm going to do is I'm going to apply voltage source over here, Vs. Okay, I'm going to apply voltage source Vs over here, and I'm going to short the other port. Okay, I'm going to short the other port. So this is V1, and V1 is also called as Vs. This is I1, and this is I2, and this current is called as I2 dash. Okay, and what I'm going to do is I need to find the equation or the ratio of Vs by I2 dash. I need to find the ratio of Vs by I2 dash. So let me find the ratio of Vs by I2 dash. So for that, let me write my Z parameter equation. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay, so now what is V1? V1 is Vs. So V1 is equal to Vs, and Z11 I1. And what is I2? If you look over here, I2 is actually nothing but the current of the direction of the current is opposite. Therefore, I2 is equal to minus I2 dash. So therefore, I can say that here I can say that this is nothing but minus Z12 I2 dash. Okay, and here if you look, V2 is equal to 0, right? V2 is equal to 0. So this will become 0 is equal to Z21 I1, and I2 is equal to minus I2 dash. So this will become minus Z22 I2 dash. Okay, so what I'm trying to do is I'm trying to find the equation of Vs by I2 dash. So so I can, here there's Vs and here there's I2 dash, so I need to remove I1 from here, so I'll express this in terms of I1. So therefore this will become Z21 I1 is equal to Z22 I2 dash, Z22 I2 dash, and also therefore I1 is equal to Z22 by Z21 I2 dash. So therefore Vs is equal to Z11 into Z22 by Z21 minus, sorry, I2 dash, I forgot that I2 dash, I2 dash minus Z12 I2 dash. Okay, and this is also equal to Z11 Z22 Z11 Z22 I2 dash minus Z12 Z21 I2 dash by Z21, or in other words Vs by I2 dash, Vs by I2 dash is equal to Z11 Z22 minus Z12 Z21 by Z21. Okay, so I found the value of Vs by I2 dash. Okay, this is the first condition. The second condition, what I'm going to do is I'm going to put the voltage source over here, and I will short the first port. So in that case, this will be my network, that is, this will be my 2-port network, and I'm going to connect my voltage source over here. This is Vs, so therefore Vs is equal to V2 and V1 is equal to 0, and this is I1 and this is I1 dash and this is I2. Okay, so now what I'm going to do is I'm going to express the Z, I'm going to apply this to my Z parameters. So V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay, and so here V1 is 0, right, and I1 is equal to minus I1 dash. So therefore this is becomes 0 is equal to Z11 minus Z11 I1 dash plus Z12 I2, or in other words I can say that Z11 I1 dash is equal to Z12 I2. Okay, and from here I don't need I2 from here, so what I'm doing is I'll express in terms of I2. So this will become Z11 by Z12 I1 dash is equal to I2. So here basically, like I said, I'm going to find the ratio of excitation to response, which means here I need to find Vs by I1 dash. So now I'm going to apply the conditioner this circuit to the second equation. So this will become Vs is equal to minus Z21 I1 dash plus Z22 I2. Okay, and but I already know that I2 is Z11 by Z12 I1 dash. So therefore Vs is equal to minus Z21 I1 dash plus Z11 Z22 by Z12 I1 dash. Okay, and in that case I can say that Vs by I1 dash is equal to Z11 Z12 minus Z12 Z21 by Z12. So this is the equation of, so this is the ratio of excitation to response in this port in this case, and this is the ratio of excitation to the response in this case. So our network is said to be reciprocal when Vs by I1 dash is equal to Vs by I2 dash, or in other words Vs by I1 dash is Z11 Z12 minus Z11 Z22, sorry, Z11 Z22. Okay, Z11 Z22 minus Z12 Z21 by Z12. is equal to, and what is Vs by I2 dash? Vs by I2 dash is Z11, Z11, Z22 minus Z12, Z21 by Z21. Both the numerator are the same, so those two will cancel each other. So finally you will have Z21 is equal to Z12. So this is the condition of reciprocity. That is, a network is said to be reciprocal when Z21 is equal to Z12. So how to find whether the network is reciprocal or not? They will ask you to find the values of every one of these Z parameters. Okay. First they'll ask you to find the values of every one of these Z parameters, and if the value of Z12 is equal to Z21, then you can say that the network is reciprocal. So that means now you don't have to apply the same derivation over and over again. There's no use of applying the same derivation again. That is why we derived it. Okay. So now all you need to do is remember this condition to check whether the network is reciprocal or not. Okay. Next, in the same way, I'm going to now tell you how to find the condition of symmetry. So what is the symmetry condition of Z parameters? So we all know when the network is said to be symmetry, right? A network is said to be symmetry. The network is said to be symmetrical when the voltage to current ratio of one port is equal to the voltage of current ratio of the other port if in both the cases the other ports, the opposite ports, are open. That is the meaning of symmetrical. So here in this case, what I'm going to do is I'm going to draw a two-port network. Okay, and then what I'm going to do is I'm going to draw, this is port 1, this is port 2. I will keep port 2 open. So port 2 open means what? I2 is equal to 0, and this is I2 is equal to 0, and this is I1, and this is plus or minus, and this is V1. Okay, I2 is equal to 0. So what I'm going to do is I need to find the value of V1 by I1. I need to find the value of V1 by I1 by keeping I2 0. I2 is equal to 0. This is the meaning of voltage of current ratio keeping the other port open. So here I2 is equal to 0. Now I know I'm not going to apply the same condition to my Z parameters because I have already applied that. If you look over here, this is the Z parameter equation. This is the Z parameter equations that you see here, right? And if you look over here, I'm trying to find the value of voltage to current in port 1 keeping the port 2 open. Port 2 open means I2 is equal to 0. So V1 by I1 when I2 is equal to 0. What is the name of that parameter when V1 by I1 and when I2 is equal to 0? That is called as Z11. So this is nothing but Z11. See, I don't even have to apply this condition to my reciprocity. I don't have to apply my symmetrical conditions to my Z parameters. If you want, you can apply. By applying them also, again, you will still get the same answer. Z11 itself. Okay, I just took a shortcut. I used the basic definition itself to describe my to justify my answer. That's all. Now this is the case. Now again, what I'm going to do is that I'm going to now reverse it, or I'm going to interchange it. This time I'm going to keep port 1 open. And that therefore that means port 1 open means then I1 is equal to 0. Okay, and then I'm going to find the voltage to current ratio at port 2, or I'm going to find the value of V2 by I2 when the port 1 is open. V2 by I2 when port 1 is open. And what is the name of that V2 by I2 when I1 is equal to 0? That impedance is called as Z22. So this is nothing but Z22. Okay, so a network is said to be symmetrical when V1 by I1 is equal to V2 by I2. That is, V1 by I1 when I2 is equal to 0 is equal to V2 by I2 when I1 is equal to 0. That is, if both the ratio is same, then only the network is said to be symmetrical. Or in other words, when Z11 is equal to Z22, then we say that the network is symmetrical in nature, or the network is symmetry. Okay. So this is how we check the condition of symmetry. Okay, we simply compare. All you have to do is, after finding the value of your impedance parameters, simply check if these two parameters are equal. If these two parameters are equal, then the network is symmetrical in nature. If these two parameters are not equal, then they are not symmetrical. In the same way, if the value of Z12 is equal to Z21, then you can say that the network is reciprocal in nature. Okay.